Lesson 4-7 will be a multi-day lesson. We're going to talk about how we count in probability. I know this seems a little bit elementary, if you will, but there's different ways of counting the possibilities in the sample space. Let's start with the fundamental counting rule. Where we have a sequence of two or more events, we can always calculate the number of possibilities using this rule. If the first event occurs m ways and the second event occurs n ways, the events can be calculated together for a total of m times n ways. The factorial function means to simply multiply together all the whole numbers less than or equal to a given number. For example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. The general formula for it is n factorial, where it's n times n minus 1 times n minus 2, and you continue that particular procedure all the way down until you reach 1. Special definition for you with factorial: anytime you see 0 factorial, it is always equal to 1. The factorial rule that we have states that a collection of n items can always be arranged in n factorial different ways. Permutations are arrangement of objects that we have in specific order. Different sequences in this case are now counted separately because they are different things. The formula for a permutation NPR is n factorial over the quantity n minus r factorial. No need to memorize this particular formula because you can always use the calculator. It's a section of your graphing. Permutations with repeating items are not in the graphing calculator. This is a formula that you'll have to remember. Permutations that have repeating items, we have to change the formula up a little bit. We use n factorial over r1 factorial times r2 factorial, so on and so forth, depending on the number of repeating items that you have. Again, as we said, n is the total number of items, r is any repeating item, and there can be several. We'll do an example of that later on. Again, there is no calculator help for this type of problem. Here's an example with permutations. Using the letters E, M, I, T, and S, how many three-letter words can be formed? We have 5 letters, and we have 3 that we have to put in a specific order. Remember that different combinations can obviously be counted here. So 5P3, when we evaluate, it's 60 different words. Now keep in mind that these don't have to actually be words, so you do have to separate your mind a little bit from your ELA studies. Here's a repetition example. In how many ways can we arrange the letters from the word eek? E obviously repeats itself 3 times in this particular thing. The number of items that we have is 4 factorial because we have 4 items. E repeats itself 3 times, so we put 3 factorial on the bottom. We end up with 4 as our answer. To the right here, you'll see another example. This one's a little more complicated. The 3 kids take turns each night of the week doing dishes. John does it 3 times. Dave and Mary each do it twice. How many different arrangements of schedule are possible? There are 7 nights, which means there's 7 items. 7 factorial goes on top. Dave repeats itself 3 times. Mary repeats twice. John was 3 times. Dave and Mary each repeat twice. That gives me 7 factorial on top with 3 factorial times 2 factorial times 2 factorial on the bottom. Evaluating that particular expression would give me 210 different arrangements of schedule. Homework after night 1 is a worksheet that was given out in class. I only want you to do the permutation questions. Combinations are a little different from permutations in that combinations are in no way, shape, or form order specific. Combination problems can be any type of these problems. For example, a selection of groups where there's no offices in particular, the forming of committees where there's no head, any problem, quite honestly, where no specific order is needed. The combination can take two forms of visual. It could be NCR, or we can use big parentheses with N on top and R on bottom. How do we find a combination? We have this formula here. And again, it's not necessary to memorize the formula, being that the formula is in the math section in your graphing calculator. In fact, it's in the same section as finding a permutation. Anytime you have two different combinations that exist, simply multiply them together to figure out all your different ways. Let's take a look at an example. Miss Jones has 10 boys and 20 girls. She needs to choose 3 for a class project. Let's find the number of ways Miss Jones can select a team if the team consists of each one of these 5 particular pieces. For any 3 students, she has 30 students total. She needs to choose 3. Therefore, we have 30C3, which gives me 4,060 ways. Now Miss Jones wants 2 boys and 1 girl. So from 10 boys, I need to choose 2. And from 20 girls, I need to choose 1. I'll multiply those 2 results together to get 900. For 1 boy and 2 girls, I'll take the 10 boys and choose 1, and the 20 girls and choose 2. From that, I multiply those together to get 1900. To choose all boys, she has 10 boys and she needs to choose 3, so 10C3 would be 120. For all girls, she has 20 girls, she needs to choose 3, 20C3, which gives me 1,140. Homework after this particular discussion today will be to finish your worksheet that was given out in class yesterday.